We are in the world of constant digital threats that originate over the internet. We call it cybersecurity threat. If you are very keen, most people want to either steal information from us or they want to plant wrong information in us. In cybersecurity, we call these people threat actors. In the world of cybersecurity, we believe that we are not safe in the digital space. At any moment, someone, your information, whether it is the data you are sending over the internet or the business email, which is a highly confidential asset, is constantly under threat. Now, it's not just about doing cybersecurity or what. It's not about being a hacker, but understanding how hackers behave or how hackers work is one of the steps you will take to secure yourself. So you will be able to identify hackers before they reach you, or if they manage to infiltrate your system, you will be able to catch them. You don't need to know how to code to do this. You can achieve this by understanding what is called information retrieval. If you go deep into information retrieval, we have what is called Pearson's correlationship, where we study relationship between two. Not to go deep into that, I've come up with this table. Let's say we have this is a threat actor, and this is the malware they have used. This is their target, and this is the attack technique. Let's say we have this threat actor, I've named in this one, and the malware they have used is here, Exagent. They target the government. This threat actor here also targets the government. This one here targets the bank. This one here targets the bank. And the malware they have sent here, they have the attack techniques here. They do phishing. This person does what's called spear phishing malware. Now I've named this threat actor here Lazarus. You see, Lazarus betrayed Jesus. So that's why I've decided to name that threat actor Lazarus. For us to understand how these threat actors behave, so we study the relationship within them, we have to think like DCI. If you see movies, you see they draw someone here, then they pin something like this, then they do network to study how these people relate. But in this case, I can say we can find a common attribute for these threat actors here. For instance, if you see the person with the APT 28 and APT 29, this one and this one, they all target government. They all target government, and they all do the attack technique they all do is called phishing. If you look at the person with the FIN7, I've named him this, and Lazarus, they both target bank. If you have a look at person, the person named FT29 and FIN7, they use a similar technique, which is spear phishing. You see, they do spear phishing, which is also another form of phishing. Phishing is also an attack method. So if we are working like DCI, now we want to catch these people, we can build what's called a relationship graph, where we can say the government, and the government has come under attack by, let's say here we have APT 28 and apt29. They do phishing. They also do spear phishing. Fin7, who targets bank, Lazarus. We can draw a graph where we study the relationship between them to understand how hackers behave. Now, here we are now not we are now thinking like the hackers. For us to catch them, we have to think like them. So we can see the pattern of their behavior, how they direct their attack, the similarity between them, and the common practices or methods they use to attack our system. Now, it's not just about drawing the graph where we can study the relationship. It's also about studying the relationship strength. For example, you can assign a score based on shared attributes. So we can say this person here with the APT28 and APT29, those that target government and they do phishing, and the score we can give it score of 2. We can say the FIN7 and Lazarus, they both target bank, and the relationship score we can give it 1. We can say APT29 and FIN7, the shared feature is phishing. They do phishing, all of them, and the relationship score we can say is 1. Now APT28 and Lazarus, they don't have shared feature. The shared feature is none, and we can say the relationship score is 0. Now, if you have a higher relationship score, this indicates these people know each other. There is high relationship. Here you can implement in real world where you are doing now security analysis, where you can link attacks to known threat actors. We can discover the threat actors groups within similar behavior. We can predict the future attack based on their observant pattern. We can also visualize the cyber threat intelligence using frameworks such as MetraAttack, which is matrix and graph databases. Now, think of each threat actor as a document, and each characteristic, which is the malware, the target, the technique, the IP address, the domain, the vulnerability, as a term. If two threat actors share many characteristics, their similarity score increases, allowing the system to retrieve related threat actors when investigating a new incident. For example, if a new attack uses phishing, which target the government agencies and deploy X agents, the system will rank APT28 as the most likely related actor because it shares the great number of attributes with the observed attack. This same principle uses information retrieval to find documents that are more similar to a user's query when you search something over the internet. Now we can use this cybersecurity, we can use information retrieval concept in cybersecurity. Let's say our system has undergone a DDoS attack. The attackers are distributed. They target our system, but after retrieving their logs, we want to start studying the relationship, to study their behavior and understand them more. We are in the digital space and we are not safe. So to secure ourselves, we not only need to put the password and the two-factor authentication, but we also need to understand how these actors behave. even in real life, how the threat actors target or pinpoint a target and direct their attacks. The mission is always to steal information or to cause damage. Mm. To cause damage, to steal information, to sniff. Hackers can have different objectives which I'll not go deep into. But if we understand the relationship between them, we'll be able to even catch them, even if they are located in China, whether they are located in which part of the world, they are not anonymous.